All right, all you square root fanatics here. We're moving on here and talking about multiplying square roots today. We've done adding and subtracting and simplifying, so we're just going through the basic operations. Hopefully you feel comfortable with what we've done so far. But here's a little warm-up, sticking to what we should already know with variables, because as we said, these act in a very similar way. So part A here, warm-up, 3x squared plus x. If I'm adding or subtracting, those have to be like terms, and they're not, so there's nothing you can do. So I guess you could either just circle it or rewrite it, I guess. Done. They're not like terms. But when I'm multiplying, and this is really where we're going today, hopefully you remember that when you multiply, I can multiply any two variable expressions. They don't have to be like terms. You just go coefficient by coefficient. Now that's really a 1 there. 3 times 1 is 3. And when you multiply variables, the same base, x in this case, you add their exponents, right? That's x squared times x, which is really to the first, which gives you x to the third. 2 plus 1 is 3, right? Because x squared is really just x times x. When you add on an extra times x, that's x times x times x. X to the third. Multiplying these two, no big deal here. Coefficient, -5 times 6 is -30, and now we multiply the variables. X squared times x to the 7th is x to the 9th. Add those exponents. Done. All right. The big idea here is this idea that when you're adding or subtracting, they have to be like terms. When I'm multiplying, I can multiply them together as long as they're the same base. That is, I can combine them. And that's really the idea here. I can multiply any two radicals as long as they're the same type of root, the same index as they call it, square roots. And that's all we're dealing with right now at Algebra 1. Algebra 2, you'll be dealing with cube roots and fourth roots and etc. mixed with square roots. So you can't do a square root times a cube root without some more advanced methods. But right here, square root of 2 times square root of 6. I wouldn't be able to add those together, but I can multiply. Square root of 2 times square root of 6, I'm going to put them both under one big square root, and what is 2 times 6? 12. And that's the idea. It's very easy. In fact, that's the property you use whenever you break up radicals into two separates. You're just using the multiplication property in reverse. So we're just putting them together. The only thing now is make sure your answer is completely reduced. 12, not a perfect square. What's the biggest perfect square that goes in? 4. Root 4 times root 3. What's the square root of 4? 2. 2 root 3. And remember, I still want you showing me that step because this is still fairly new and I want to make sure you're really doing it and getting it. But in geometry, algebra 2, they'll start to let you skip steps and jump right from there to there. When I'm multiplying two radicals and they have coefficients, no big deal. Just like with variables. You multiply the coefficient by coefficient. 2 times 6, 12. Root 5 times root 3 is root. 5 times 3 is 15. Put it under the house there. 12 root 15. Now, can root 15 reduce? Breaks down to 5 and 3, but neither is a perfect square, and that's it. Root 15 is completely reduced. Remember, you're only trying to reduce the square root here. 12 is just a regular old number 12, so leave that alone. -5 root 8 times 3 root 6. That's going to give you -5 times 3, -15. Root 8 times root 6. Root 8 times 6 is 48. 48, not a perfect square. Let's reduce. I like to go with the biggest perfect square, and by now you should have seen 48 fairly often that you bypass the 4 times 12 because that'll take 2 steps and you go, hey, that's 16 times 3. 16 being the biggest perfect square that goes in. The square root of 16 is 4, so that becomes a 4. Root 3 stays root 3, and now you've got -15 times 4 on the outside, so we multiply those, and that's -60 root 3. Done. Radical completely reduced, and that's that. All right. Now let's take a look at these. These actually are a little pretty easy, but you might notice something that we're really going for here. Root 5 times root 5 is root 5 times 5 is 25. And now what's the square root of 25? Well, 25 is a perfect square. The square root of it is 5. No square root left over, no reducing. So root 5 times root 5 gives you root 25, but then that just ends up being 5. Root 7 times root 7 is root 7 times 7 is 49, but the square root of 49 is 7. No square root. So I'm really after this idea of, right here, seeing this, that if you do the square root of a number times the same square root, you're always just going to get that number, because this middle step, you're just creating a perfect square. That's, that's just 7 squared right there. And the square root of 7 squared is, of course, just 7. So root 93 times root 93, I don't know what 93 times 93 actually is off the top of my head. I could use a calculator. But you know what? I know the final answer is, it would be 93 squared, which is a big number, but the square root of it's going to be 93. And that's what we're going to be using in the next couple days, this idea that if you do the square root of a number times the square root of that same number, you just get that number. The square root is gone. Okay, so what if you're doing that and it's got a coefficient out in front? 2 root 5 times 2 root 5. Well, that's still 2 times 2. So 2 times 2 is 4. Root 5 times root 5. Take your time if you like with this. Root 5 times root 5 is root 25. But then what is the square root of 25? 5. No square root because it was a perfect square. But now you've got two numbers being multiplied. 4 times 5, 20. So if you want to start to skip this step and go straight to here, that's fine with me. I want you to get that idea that root 5 times root 5 is just going to be 5. But I also don't have a problem if you write that middle step to help you, kind of build that perfect square and then take its square root, whatever works for you. 3 root 7 times 3 root 7, just don't forget the 3's. 3 times 3 is 9. Root 7 times root 7 is going to just give you 7. Yeah, root 49, but that's 7. And 9 times 7, 63. And writing it this way, 2 root 3 squared, remember to square this whole expression means you're really doing 2 root 3 times itself, times another 2 root 3. So if it helps you to write it out that way, so 2 times 2 is 4. Root 3 times root 3, it's the same square root. So I'm just going to get that number. I'm going to get root 9, which is 3. And 4 times 3 is 12. If you like, you can, sort of bypass this step of rewriting it twice. You could just say, look, I'm going to square both things, because we've done this a lot. That's 2 squared, and then root 3 squared. 2 squared is 4, root 3 squared is 3, 4 times 3 is 12. It's all the same however you get there. Negative 4 root 3 squared. Now, come on, you can't make this mistake at this point where we're almost to June here in Algebra 1. If you square a negative number, and that negative's on the inside of the parentheses, is your answer going to be positive or negative? And if you're thinking negative in your head right now, then shame on you, but don't tell anybody. But you're really doing negative 4 squared, negative 4 times negative 4, so that's positive 16, and root 3 times root 3 is root 9, which is just 3, and 16 times 3 is positive 48. But yeah, if you were doing this here, negative 4 squared times root 3 squared, that's going to give you 16 times 3, 48. But if you want to write it out twice just to be safe, that might be a good idea. Now, this isn't going to be happen all that often where you're always, multiplying a radical by the same one, but it's going to be useful for something else we do. You're going to have a lot that are more like, this variety. Hey, you're just multiplying 2 random square roots, and then you might have to reduce it. So just good to be comfortable with everything that comes your way in this. And as always, if you got any questions, watch the video again, email me, come to a Zoom, something, reach out, and we'll get it straightened out. All right, kids, hang in there. You're doing great.